Hello developers, welcome to the playlist TypeScript with tapaScript. I hope you are enjoying this playlist and we are now talking about types. In the part 2 of learning the types or knowing the types, we are going to talk about a vital aspect of TypeScript. We will be learning about type aliases and interfaces. Whether you are programming on standalone TypeScript or with React or with Next.js or with Angular or with whatever, wherever TypeScript is there, you will definitely see type aliases and interfaces. In this video, we will be learning about type aliases, interfaces, and the differences between them. Also, we'll come to know when to use what. I'm sure you don't want to miss that. So watch this video, and if you like it, please post a like, please comment on this video and share this one. And one request that I always do, please subscribe to my channel because it motivates me to create a lot of awesome content to teach you, to share my learning with you. All right, so without any further delay, let us get started. Hey people, we are here again with our setup, the setup that we have been seeing for last few videos and using it, where we write the TypeScript code and it compiles to JavaScript code, and we are having this particular terminal open at the right side where I am running TypeScript compiler in the watch mode so that we don't have to really worry about running it again and again, right? So that's the platform that we are starting with. Now to get started with type aliases, let me explain what exactly type alias first. In TypeScript, we have various types that we have already dealt with in our last video. If you have not watched that, I would really encourage you to watch that first and then come to this one, where we came to know about basic types like number, string, boolean, etc. Then we understood arrays, we understood objects, we understood tuples and various things around them, right? Now those are the types from the language itself. But at times you have to support certain kind of shape for your data. What exactly shape for a data mean? For example, you are dealing with users. Now users may have user ID, they may have name, password, various kind of things. Now you have to create a data shape for your user data. So you will be thinking about, hey, I will have a user, and for the user, I will have a username, password, address might have the street name, country, etc. Right? Now, if I have to create this shape of data and the same shape of the data I have to use throughout my application. Now, instead of creating this again and again in different places, I can now create something called a type aliases. Using all the basic types that TypeScript supports and create a name. Aliases means a name, not a new type in the language, that I can reuse in multiple places. Now to take a smallest example of it, let's take a look into this VS Code. When you create a type alias, you have to give this particular keyword called type, and let's say I'm saying magic number equals to number. So here I am creating a type alias called magic number using the keyword type, which represents number everywhere. So it means if I say const t-shirts, how many t-shirts I have, and now instead of saying number, I can now say magic number and say I have 20 t-shirts. And if you see here, this found zero error. That means it's a proper syntax that I have used. Now here I am not using the number directly, rather I am using the type, the aliases I have created to represent something called number. Now this is a very basic example, right? This example doesn't make much sense. Now let's get into an example which would make much more sense. So for example, let's take another type which is a complex type, and I will be creating a shape of an employee. Shape of an employee means what does an employee might have? The employee might have an ID like an employee number, can have a name which is of course gonna be a string, can have an email address, again it's gonna be a string, it can have a salary which gonna be a number, right? So I have an employee type right now. As I have this employee type, that means I am going to create a shape for my employee object throughout my application. It means if I have to create a simple employee object, so for example, const Adam as an employee colon, I'll be creating like now employee, and here I'll be giving the employee definition. Okay, before I provide the definition, I want you to recognize the syntax here. What we are doing here, we are creating an employee called Adam, and the type of the employee we are giving as employee is the same way how you used to create const address colon string equals to one address. Okay, so here instead of giving a basic type that TypeScript supports out of the box, we have created a new type aliases, and we are using that as the shape of Adam and its properties. Got it? Now again, to reiterate, the type that we have created, the type aliases that we have created, it doesn't create a new type in the language. Rather, you are creating a new type name that you can reuse in multiple places using all the basic types from the TypeScript. Now, if I have to create Adam using this particular type, I would straight away say is ID is say 234 because we have given a number. Name is Adam. Email, we can say adam@email.com. Salary, let's say this much USD, right? Now I have created Adam and I see found 0 error. If I do console.log Adam, and if I do node this / the same file name, because the JavaScript file would have got created under the disk folder we have seen in the previous videos, I would see the entire Adam object being printed here, correct, without any error. So that's fine. That's great. So we have created a type. That's great. But what's the real advantage of this? Now the real advantage is we have created the shape for an employee. So it means if I am going to alter or by mistake going to give a different type or definition for my employee's properties, TypeScript is gonna catch it. So for example, by mistake, if I'm saying the salary is a string over here, I'm gonna get an error, right? We're going to get like salary is a number I really cannot give, right? So it means the structure that I'm creating for an entity, the structure and the type is really forced very strictly through the type aliases. And it's not only just that. So for example, at a certain point in time, I feel like, hey, okay, I have an Adam employee and I just forgot to put its address. Adam's address I have to put, and I go ahead and say address : say Austria. Now the moment I put address, I'm still getting an error, and the error says object literal may only specify known properties, right? It means that though I have put Adam's address over here, it is not known by its shape and the shape definition that we have provided through employees. That means employee doesn't have this address definition at all. Now, if I go ahead and add address over here, I won't get this error because now address is defined in the employee shape, and this is great. Now, at the same time, if address is available in employee and I'm not providing this address, I'm still going to get an error saying that address string is declared over here and you are not really giving a definition to this. You are not creating the address properly for employee. So this is another way that you are getting caught while coding itself in your compilation time itself before you go into production and the runtime. Now, in some situation, it might happen that you really don't have a need to provide an address of an employee. Let's say address is an optional field. Now, how do you handle that? Would you still provide address like this and give it like an empty string? Could be a way, but this is not the right or probably not the best way of handling this. Now, the best way of handling that would be, if you remember, we spoke about that optional properties in our last video. We spoke about that interrogative symbol. So you can mark any of these properties in the type definition as optional, so that when someone create an instance or data out of the type, they can optionally ignore that. So for example, in this case, if I mark address as an optional property, you see that error has gone. So it means that now if I create employees, I may give an address or I may skip giving an address. So this is how it is pretty powerful, and you can provide the shape of data the way that you would like to. As we speak about the type aliases and how helpful it is for providing the shape of an entity in TypeScript programming, we can also create nested type aliases. What does it mean? Nesting means you have some entity and within that you have another entity nesting. So it means that we have employee. Now think about a department. The department may have multiple employees, right? So you can create a type like a department, and you can say the department shape is gonna be, there will be a name which is of type string, and department may have multiple employees. So employees, and it can be a array of employee. We have seen array in our last video. We came to know and understood where we learned how to create an array. So here exactly the same way I'm creating an array, I'm saying that the employees will be of type employee, but it is not just the employee, it's an array of employee. So now it means I can create a new department, say sales, and I can create it like, of course I have to give the department as a type, and I can say name is a sales department, and employees, I can put how many of our employees I want. I can put Adam, for example. Adam is an employee. So this is a valid data that I have created from this particular type shape or the type definition. So you see how the types are really useful in TypeScript. You can create types, you can give shape, you can create nested types. So it means you can create one type and reuse it somewhere else in another type. You can do all sort of things. All right. So we learned about nesting, where we could nest one type to another. Let's learn about composition. What exactly composition means? So for example, you have say multiple types, you have two types. Now you can compose those two types to create another new type, aliases. How do you do that? You use the union operator. Again, union operator we have touched base in our last video, and now we are extending it to creating type aliases over here. That's how the videos in this particular playlist of the series is gonna be. You must watch the previous one so that you can have a continuation on the future one as well. So let's create a composite type alias name. We'll create something called say ISBN, and we are saying that this ISBN type, it can be a number type or a string type. So here we are using this union operator, as you see over here, to say that I am making a composite type called ISBN, which can be a number or a string. So now I can create like const book ISBN 1 colon of type ISBN, and I can pretty well tell that this can be a number, a valid one. I don't get any error. Same thing, I'll just copy, paste it over here, change it so that there is no name conflict, and here I can put a string, something like this. This is also valid. So you saw that how we have created a composite type definition from the existing types, right? In the previous one, we have used the existing type to define the shape. In this one, we have used the types to create a composite type alias name, right? So this is also very much possible. Union operator is very helpful for creating the composite type alias name, but there will be occasions where you have to create like an extension of one type to another. You know, extension like the kind of inheritance, like you have something called base type, and from the base type you extend and create some other specialized type. From that specialized type you can go ahead and create another kind of specialized type. So with that you can create different types from the base type that is available. So for example, you might have a base type called user, and you want to extend that user base type to create an admin user, or you want to create another normal user, or you want to create something called a customer. So different kind of user base shape or the type definition you want to create from a base user type. How do you do that? You do that using another operator called intersection operator. The intersection operator is defined by this ampersand symbol. So now we are going to create a type called a base type, and we are going to extend it using this intersection operator to create a new type. So let's do that. So first, let us create a type called user. Here we'll have say ID, we'll have a name, we'll have email, we have password, etc. Some basic things. Now I can extend this user to create an admin user. So for example, I can create like type admin equals to user. Notice this ampersand and here I can provide the additional properties that are required. So for example, I can say the user role in this case can be of admin. All right. So I have an admin user. Similarly, I can also create something called customer, and I can say this can be a customer. Now I have extended this particular type alias to create an admin, and I have extended this type aliases to create a customer. So what I can do, I can now create an admin, basically the admin data. So how do you do it? Const admin colon admin, and here I will be giving all these properties. So for example, I have to give ID, I have to give a name, say Bob, I have to give an email, and then I'll be giving a password. Okay. Now if I stop here, you see the error over here. The error specifically saying the role is declared, but I have not really put that into my data. Now I have to mandatorily put it, because previously itself we came to know by rule that if you have something in your structure, in your type alias structure, when you're creating data out of it, you have to provide mandatorily the definition of each of this attribute unless you have marked that as optional explicitly, right? In this case, as we have not done it, so we have to provide this role called admin. Now I have an administrator. Now this is a very strong point, because you have something very base which you are not repeating in each of these different type, rather you have extended it. Now I'm creating a customer data, cust, given an ID, name Alex, alex@example.com, a password. Now by mistake, if I give role as admin, I'm still going to get an error, because if you're creating a customer from the customer type aliases, it is role has to be a customer. So to fix it, I have to give it as customer. So this is how I extend type aliases to create different types, and for that I'm using this particular operator that you have to keep in mind. There are many amazing use cases of type aliases. There are another amazing use case which is not very well known, that you can create type aliases using template literal. In JavaScript, you know what template literal is, right? There are backticks like that, and in the backticks you can write Tapas is a dollar type boy, do things like that, right? Const message colon string equals to. Now this dollar type can be an expression which is like const type colon string equals to, let's say, good, correct? So it will become Tapas is a good boy. It's like that. So this is how the template literal and the expression works. Now you can use the power of this one to create new types. How? Let's create a type called starts with tapaScript. Okay. Now this type, I'm defining that it has to start with this particular string called tapaScript. After this, you can put any string inside it. Okay, as simple as that. So it means if I now create a data using this particular type, let's say TS YouTube, which subtype start with tapaScript, a valid data could be which is starting with tapaScript, YouTube channel, I won't get any error. Now, if I don't start with tapaScript, I would certainly get an error, because it says the type YouTube channel is not assignable to type this, because it has to start with something called tapaScript. So in this case, it is mandatory that the string that I'm creating over here starts with tapaScript. So see, you have now created another structure, and the structure is such a way that you can pass a dynamic data over here, a dynamic value exactly for over here, and using that you can create a new kind of data which has its in-place validation itself. So in this case, the in-place validation is that it has to start with a particular string that you would like to. In this case, it is tapaScript. Let's learn another great usage of type aliases. So far, what we have done, we have created kind of complex structure, like an array-like structure. We have done some kind of string stuff. We have done some kind of number, and with that, we know like other types like Boolean, arrays. Arrays also we have seen actually while creating the department, while nesting, composing, it all good. But we have not taken anything like a function. Now with type aliases, we can do stuff, we can do wonders using functions. So for example, I can do things like type, and I'll say calculation, CLC calc, where it can take a function like say A, and A can be a number, and B can be another number, 2 parameters, and it produces a new number, right? So we are calling this as type calc. How is it useful? This is extremely useful. It can be like const sum, and the type is calc. Look at this, okay? And here we can pass P comma Q can result into P plus Q, like this. So it means P comma Q can result into, can return P plus Q. Now the sum is of type calc, because calc define things like this, where you can take 2 parameters and produce a number. In case of this, it takes 2 parameters, right? And then it produces a number. Now I can actually do multiple stuff with it. I can now define a mul function, not malfunction, mul function, where I can say P into Q. Now how can I produce result out of it? I can definitely do sum of 2 comma 3, a valid syntax. I can do mul of 5 comma 6. Now let me put them into console log. All right, like this. Now let me run them. You see, the first one is 5 because 2 plus 3 is 5, and then 5 into 6 is 30. All right. So this is the usage of type aliases. I hope you understood type aliases. Now we are going to talk about interfaces a bit. The usage of interfaces, the look and feel, the work that is doing, or the purpose it is solving is mostly like type aliases. And then we will clarify what's the difference between type aliases and interfaces, and when you should be using which one. Let us start by understanding interfaces first. Interfaces are another way to create the structure for your data in such a manner that whenever you're creating the data, you have to adhere to that particular structure. We create interfaces using the keyword called interface and then giving the interface a name and then define what are the properties of the structure that you want to opt for this particular interface. Now for the naming convention, interface name starts with a capital letter. In some cases, we also put an I in front of it to tell that this is an interface. So now let's create an interface called iCustomer, and here we will have property for customer like a name and an address. All right. Now here you have to notice one thing. When we were creating a type, we were giving it as a type name equals and then defining whatever the type aliases that we wanted to create and what could be his definition. In this case, we are defining the interface with the interface keyword and the name of the interface followed by these curly braces, and inside the curly braces we are actually defining the structure of the interface. This is more like an object kind of syntax that we have seen in JavaScript, right? Now from this I can now create a data. So say const Milano, say one customer, iCustomer equals to name could be Milano Corporation and then address Germany. Okay. Now I have created a new customer data using the iCustomer interface. Once we have interface, we can also create classes out of this interface by implementing this interface, right? So for example, I can create a class, say Golden Chase. Here I'll be using the keyword called implements and we'll say iCustomer. Now as it is a class, I have to define the property of this class, and this is where the great thing about interface. When you want to define the property of this particular class, it has to adhere to the structure that you have defined in the interface. So for example, there has to be a name, there has to be an address. Okay. After that, as it is a class, you will have the constructor as it is. You will say name string, address string, and you will say this dot name equals to name, this dot address equals to address, right? So this is your new customer class that you have created by implementing this interface so that you can adhere to the construct or the structure that you have defined in the interface. The structure is it must have a name and address. Now as you have a class, you can now create as many instances of this class possible. So for example, if the Golden Chase is in Bangalore, I can say const Golden Chase Bangalore equals to new Golden Chase. The name could be Golden Chase Arcade and it's in Bangalore. I have a new instance of this particular class which actually having a construct, the structure that is given by this interface. You may ask, I have created a particular class from an interface. Can I do the same thing with types? What do you think? Let's try it out. Now I'm going to change this guy from interface to type, and for that I have to give a equals over here. There is no error at all. It's a valid syntax. So either you create it from an interface or you create it from an type or a type aliases, you can do exactly the same thing. Now if I am doing exactly the same thing, then what is the difference between types and interfaces and what to use when? So let's get into that. Interfaces, as you're looking into the structure by itself, the structure itself is derived from the JavaScript's object structure. Now object in JavaScript is the prime, the object define everything. Now if you have to deal with objects, you have to deal with the extension from one particular interface to another particular interface using the extends keyword, something like this, where we have created a new interface called AusCust, means Australian customer, for example, which extends the iCustomer and having one additional property called location. Now if I have to create a data out of AusCustomer, I have to give name, address and location, all these things, right? Now if you have to handle only this object kind of data structure or the data, I think it's good to go with interfaces because that come organically into the language because it's supported by JavaScript organically. But there could be situation where you want to go beyond this type. For example, we have created types like type test equals to number or string. We have created things like this. We can in fact create things like type movies equals to horror, comedy, romantic. Now here the test can be used as const random colon test equals to text, or it can be a number as well. In fact, you can create interface A and interface B and then create a new type called AB, which can be like interface A union interface B. Now, this particular flexibility is not achievable using interfaces. So, in case of interfaces, you cannot use this union operator to create a new interfaces altogether, right? For interfaces, it will be always by the structure which look like an object. So, that is where the types might come handy, because you might want to create your type aliases or the type definition which is of this nature. And this will happen again and again in your programming with TypeScript. You would do it. In those cases, you would always go for type aliases over interfaces. Then another differences would be, in case of interfaces, you can actually open it up to extend it. But in terms of type, you are not opening up to extend it. Rather, you are creating another type aliases name, another operator like intersection operator. This is how you should be seeing the differences. Now, which one to use? I told the circumstances, like in case of types, there are really some occasions in the situation where you have to go for types. So please go for types. But if you know the structure is just like an object kind of structure like this, you can actually go for the interfaces. Hey, so I hope you found this definition helpful. You understood what is type aliases, what is interfaces, and the differentiation between them, what to use when, with lots of examples that we have seen. In the next video, we will learn few more things from TypeScript with again a lot of code and example and hands-on exercises. Don't forget to subscribe so that you don't miss out on the videos that I'll be creating. And if you like this one, please like and comment and share this video. Thank you very much. Stay well, stay healthy, keep learning.